right, thank you, and good morning, good afternoon, good evening, wherever you are. We're happy to be here, even though it's early for us in France and Morocco. And so today, as Padma has introduced, we'll talk about Liquibase and how Liquibase and Neo4j work in particular together. And so, yeah, let me switch slides. It's a bit slow on my end. So my name is Florent. I work at Neo4j indeed in the drivers team, and I initially authored the Neo4j plugin for Liquibase, which we're going to talk about today. And Marouane, what about you?
Yeah, I'm Marouane Gazanayi. I'm a field engineer in the piece MEA, and I'm contributing occasionally to Liquibase and using it on daily basis.
All right, thank you. So first of all, we'll try to answer, the most pressing question, like why should you even care about this topic? Like what are we even talking about? What's migration? And then we'll get into some more subtle concepts about, how to deal with migrations when you're with a relational database or when you're with Neo4j, like what are the specificities of Neo4j in that case? And then, of course, like why Liquibase and why not some other tools, right? Because there are always different options depending on what you want to do. So yeah, let's start with that. What do we mean by migration, right? Because it's a bit of a loaded term even in the Neo4j landscape. And so migration means, from the very high level, right, moving the database from one state to another, and then yet to another, to another, to another, etc., by applying a set of changes. That's really what we talk about here. And what do we mean about state? We don't mean the internal format that is stored on disk, right? Because there is indeed some migration utility when you upgrade from one Neo4j version to another. But that's not what we're talking about here. We're really talking about the data and the schemas that you as a user can see, not something that is stored on disks. So that's what we talk about when we move from one state to another, like the visible state you can see yourself when you're using Neo4j. And, even when we talk about states, it's not always completely clear. So Liquibase has been around for a long time. And its first target historically has been, relational databases. And what you want to manage with Liquibase when you're targeting a relational database is mostly the structure. So by structure, I mean I want to create a table and then another one, and maybe there is a foreign key between them, and what is the primary key, what are the uniqueness constraints, etc., etc. So you're mostly dealing with structure. And when it comes to Neo4j, well, of course there is structure and there is data, but the thing is there is no strict separation between the two, right? The data is a schema, the schema is the data, because you could go, you could have a lot of fun with Neo4j and get very heterogeneous data, in which case maybe there is no easy to infer schema. So that's possible, right? Neo4j started as a schema-less database, now it is a schema optional database. And you can only infer the schema from what is stored in the database. So that's something also a bit specific, which may have some implications on how Liquibase is used in those scenarios, right? But we can come back to this if there are more more clarifications needed on that topic. But that's something to keep in mind, right? In the relational world, it's easy and cheap to create a database or maybe rename a column. There are not too many rows. In Neo4j, if you want maybe to change the shape of a node and you have a gazillion nodes in there, maybe it's not as cheap. So these kind of implications, are important to keep in mind. And so, so that's what we want to do with Liquibase, right? We want to move from one state, so data schema, to another by applying a series of changes. And why Liquibase in particular for that, right? Because you could still script it yourself, which is one option. And, we've been doing that for a lot of time before. But of course, it's error prone, right? You can mess up the script themselves. You can forget to run one script. You can also, especially if it's not versioned, then, it can be, you run into a lot of issues if it's not automated. So Liquibase brought that, right? Back when it was first introduced in 2006. Like versioning comes by default. You version your Liquibase files just as with any other file with Git or any other system. There is the automation of the order, of the execution. There are some concepts that comes for free that will really ease your life. Very easy to integrate with CI. There is also rollback support. You can tag things and go back to those tags, so you can come back to a previous state. So there is all of this that is built in, and we'll come back to that in detail, right? So that's first, the first big aspect, automations, locally, in CI, in production. So that's really something you want to achieve, right, when you're managing databases, Neo4j or not. And then, while Liquibase in particular as well, it targets many databases. Historically, it's been mostly about relational databases, but it's not true nowadays. Obviously, there is Neo4j. Marouane and I are actively working on it, and we hope you too at some point. There is MongoDB, there is Cassandra, there are many others. So yeah, it's not only about relational databases. I believe today it's more than 50 different targets. And that's quite important, right? Because even if I'm working for Neo4j, quite often the customers already have some persistence solutions for some areas of their products, right? So Neo4j is not always the sole database that is existing in an information system. So that's something we need to keep in mind. And guess what? Liquibase is well established. So maybe there is already Liquibase in your company. And so if you want to have the same kind of comfort and support, well, you don't have to switch tools and relearn all the concepts of that tool. Liquibase is supported for Neo4j as well, so that's also something to keep in mind, right? You don't have to drop all the knowledge you gained using Liquibase for a relational database. You can also, exercise that knowledge and apply it for Neo4j. And as I've been telling you, Liquibase was created in 2006, one of the first tools of this kind, which brought many of the database refactoring ideas to fruition. So it's been open source for more than 15 years. It's been battle tested. There are many customers out there using Liquibase, many users. It's a strong community, very active. And then, it's all about, being declarative, declare what you want, and then Liquibase will take care of the nitty-gritty details of making it happen against your target database. Portability was also a strong point in the relational world, not that much for Neo4j, but that's also something that was a strong selling point back in the day. And with that in mind, we'll probably going to switch to Marouane. So let's talk a bit more concretely about the concept of Liquibase. So Marouane, up to you. I will stop sharing my screen if I can find my mouse, which is somehow there. All right, so Marouane, up to you.
Okay. So normally my screen is shared.
Yeah, someone needs to put it in foreground. Here we go.
Okay, perfect. So as Florent just said earlier, what you learn here in this next session, it applies to every kind of databases using Liquibase to handle the migration. Okay, so we will see the basic concepts of Liquibase, and especially Neo4j Liquibase. So first thing, you need to install Liquibase, Neo4j Liquibase plugin to use it, and there is different ways to use it. Okay, if you don't have any application running under a JVM, you can just go and install the CLI tool, okay, which will give you the ability to execute all your changes, etc., against a database. So you can install it either by Homebrew, Chocolate, or use the official Docker image that contains directly the CLI, and then execute everything through your favorite Docker container. And if you want to use the low-level APIs or the core Java APIs, you can also do it, okay? Once you have the core library, you just instantiate everything by hand using Java, and you just do the work. You can also include the plugin using your favorite build tool, okay? Maven, Gradle, or Ant. And if you are already using Spring Boot, here all the magic happens, because you need only to configure a data source after, of course, including the plugin, and everything will be magically, how to say, configured for you. Okay, there is also a Java EE CDI integration that if you are on, you can obviously use Liquibase for Neo4j. Okay. So once you have installed Liquibase Neo4j, what you can do? Okay, you have all these commands to execute on, of course, all the databases. But if you run, for example, an update SQL, okay, this is a dry run to test your change sets against the database. Okay, it will give you the possibility to test if everything is okay, or not. Then you can go and run an update directly. You can have the history of all the changes on a given database. You can tag a state for your database and just start again from this state, etc. And you can, of course, roll back to a specific tag if you want to revert your changes. So now let's talk about the building blocks of Liquibase. First thing, which is change logs. The change logs are the single entry points for Liquibase. Okay, they are loaded from different locations, but we load from disk twice all the time. Okay, so you have some files that describes your. Okay, in your change set, okay, you can define them using different languages, okay, especially XML, JSON, YAML, or SQL. And inside each change set, you can include other change sets. This will help you to keep things clean, okay? So you can have a change set describing what you want as change, etc., etc. Next comes a change set, which is by default immutable, which means that you can't change the content. You can do it, but by default you need to keep your changes immutable. Don't change them, because internally Liquibase will do some calculations to know if this change set is already has already been executed or not. These changes are incremental also, so we'll describe, for example, the first state you want, then the second, etc., etc. And by default, each change set will run in its own transaction. So if something fails, it will stop right there. Okay. And just to note something, in Neo4j, the schema operations cannot be mixed with the data operations. If you create constraints, you can't execute in the same time some data operations like insert, merge, say, create, etc. So, as we said, each change set is uniquely persisted in the database and is incremental. Okay, each change set has its checksum, so it gives us the certitude that it doesn't change. This is how we will know that this change set has changed or not, and we will not execute it again. And as we said, also it's transactional. If an execution is interrupted, so all the change set will fail. Okay. And here we come to the smallest portion of our change set, the change that can be a simple Cypher query running inside a SQL tag, okay? Or it can be a more complex concept like a refactoring call to merge nodes or rename foreign key or something like this. We will now take a look at a demo. I will switch back to Florent that will show you all these things live. Thank you.
Thanks, Marwan. I believe there is a question in the chat, which is, and I will read it here. Does Liquibase connect with Neo4j, using the driver and sessions, and can it work with multiple databases? So for the first part of the question, does Liquibase work with Neo4j? Yes, and that's what the demo is about, right? That's what we're going to show, hopefully. And hopefully it works with Neo4j. And so to answer, does it use driver sessions, etc.? So that's the second part of the three-part questions. Yes, but not directly. So that's an interesting point, is that we're using the JDBC connector. And you might ask, why are you using a JDBC connector? So the JDBC connector for Neo4j uses the driver under the hood, right? We didn't re-implement the whole connectivity low-level bits that the driver implements already. So we took the native driver, we wrapped it in JDBC, and that's what Liquibase uses. And the reason for it is quite simple. as I've been telling at the beginning, Liquibase historically targets relational databases. And what is, the golden standard for connecting to databases in the JVM world? JDBC. So it was much easier to bootstrap the whole Neo4j plugin with a JDBC connector than doing it from scratch. Does it mean we'll stick forever with a JDBC connector? Maybe not. And that's something we are considering at the moment. But so you won't see in the code, if you look at the code of the plugin, you won't see something like directly with sessions, etc. But under the hood, that's what happens, right? We open a session, we open transactions, and we run statements in there, but through the JDBC interface, really. And the last question of that question, the last part was, can it work with multiple databases? The answer is yes and no. So for a single run of Liquibase, what happens is we're going to target a single database. Like we are not storing the history. Can you still hear me, by the way? It seems I don't know. Let me see. Am I still here?
Florent.
Okay, okay, you hear me, so that's good. That's the most important.
I think we lost Florent.
I'm back, but someone needs to leave me in.
Yes, we can hear you, Florent. Okay, go on, please.
Yeah, I need to be back. La 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 la. I'm not sure I'm back. I'm still in the backstage. All right, I'm back, and sorry about that. So yeah, I was saying, so I was trying to answer the third part of the question, like, can you connect to multiple databases? The answer is yes and no. The recommendation is to target one database for a single run because the history, the persistence of change sets, like what we have run, we need to memorize what has been run and what's not, is stored in the same database as your target when you want to run migrations. So yeah, so we can target multiple databases, but not for one execution. One execution needs to target a single database. So you will have your history persisted there and the migrations themselves. All right, so let me share my screen because I want to show you a little demo to not only talk about what Liquibase for Neo4j can do, but show what it can actually do. And so the screen will be back soon. So we have a simple data set. We didn't want to keep things too complex. We have a set of countries that we load from a flat file. We have a set of companies located in those countries, and you will be impressed by the number of countries and companies we have. It's gigantic. It's like 5 countries and 6 companies. So really something very simple. And then the application also manages persons living in those countries and working for companies, right? So very simple data set. And we'll see how it looks like. So first, what's next? I'm spoiling myself here. That's not nice. So let's look at the application. So we've told you, Marouane told you, right, that you can use Liquibase in a variety of ways. This time we're using Spring Boot and Spring Data Neo4j. So Spring Data Neo4j to map the data from the database to actual Java classes. And we're using Spring Boot because just with this configuration, so the first bit here is about Spring Data Neo4j, like what database should be target. Then, as Marouane told you before, right, we just need a single JDBC data source, and Liquibase will be automatically configured with that. So we tell him, hey, we're using the JDBC driver, we're using a bolt connection, so point-to-point connection. We're reusing the same credentials because it's the same target, obviously, and then we just need to tell, hey, so there is a default location, we just change it, so you could even do with this parameter, without this parameter if you use a default location. So that's all you need to get, so that part in particular, that's all you need to configure Liquibase with Spring Boot because the auto configuration takes care of the rest. It sees that, it sees what you have on the class path. And here we go. So let's see. First, what do we have? We have a changelog XML. Again, it could be YAML, it could be JSON or SQL. You can also mix the formats if you like. And so what we do first, and something we've not talked about, we have, as you want always to start, you want to make sure you have the good constraints and indices in place. So we do that for countries and for companies, but the syntax varies from version to version. So it used to be create constraint on, assert, blah blah blah. Now it's for and require. So that's why we made a precondition, which means if the database is Neo4j and the version is either 4.4 or 5, then use those. And here we kept it simple. If the precondition is not met, if one of these bits is not true, then you will hold the executions there. So there are different strategies actually when the preconditions are not met. You can ignore that fact and skip to the next change set. You can do several things. Here it was just an excuse for us to show how you can conditionally apply change sets. And change sets, would be nothing without changes. So here we have a simple Cypher query. So both of them, constraint and index. So you can use constraint and index in the same transactions, but you cannot run a regular Cypher query in there as well, right? That's a constraint from Neo4j itself. So you need to split them. And so I see Reuven is asking, I was sure I would get a question like that. Yes, it works with routing drivers. It's just going to be Neo4j here, and then I believe the name is Vault routing driver. I don't remember the name exactly, but the name will be slightly different. That's something very specific to JDBC. And the reason we are not using Neo4j here is really random. We have a single local database, so we kept things simple. But yeah, we could use Neo4j here. It will work with single instances anyway. So it really doesn't matter. It's just use Neo4j scheme instead of Bolt, and make sure to use the right class name, which I don't remember at the top of my head, but yeah, it's just a matter of configuration. So yeah, it's probably even nowadays, in the old days, the Neo4j scheme was not supported against single instances, but it's not true anymore. So it's probably a safe bet to use the Neo4j scheme anyway. So thank you, Reuven, for this question. And so back to our dataset itself. So I told you we load some seed data. So load data is not about application data, right? It's on the applications that you will be insert. Like if you're an e-commerce website, you're not going to load transactions this way. The application will generate those data. So it's mostly for reference data, what we call seed data, really. So we have, a gigantic amount of countries, as you can see here: France, Morocco, Turkey, and Japan. 4 countries. Whew, that's big data right there. And we have the same construct here with companies. And so what's interesting here, so especially with companies, right? So let's look at companies real quick. Companies have a name, they have a country, and they have a domain, which is, again, very handwoven. We made up our own, so it's not necessarily completely accurate, but yeah, please bear with us. So we have name, country, domain. However, the way we modeled our company entity, right, in the Java world, we want more something like this. We want a company, which is a node, right? It's a set of nodes, which has a name and has a relations to countries. And you can see here, the country is actually part of the CSV. So let's see how we deal with that. How do we extract this country away from company and, understand it's a node and link it to there? And Liquibase can help in that scenario. And I will come back to the other question right after that, I promise. So first we'll load countries, pretty easy countries. The thing is, the property is called country, even though we decided to name in the Java world. So something very easy, the colon is called name, and we decided to call it country. So the header in the CSV is name, the actual property will be country, and then we load data, it will create 1 node per row, and here we have our country nodes. Then we go to company. So same thing, here name will remain name, country will be country, just another way to do the same thing. You can also specify types if it's not strings. And then the domain, just another way to access the column in the CSV. It can be by name or by index. And at this point, we have companies, with this extra properties that we don't want. And what we can do, so far we've seen, simple changes like a cipher query or, some specific standard construct of Liquibase load data. And now, let's do something a little more complex, right? Because we don't want company nodes with a country property, because countries are proper nodes. We want companies linked to countries. And how do you do that? Well, we have a brand new refactoring called extract property, and brand new thanks to Marouane efforts. So he worked on it. And what you do basically is say, okay, I want to match these nodes, so the company nodes. So the company nodes, it could be a complex query fragment. So that's why you also need to say, okay, what is the variables that actually denote those nodes? Because there could be several variables in there. So I match those companies and I want to extract the country property. And what do I do with that? Well, I will extract it to those nodes. So I want to create nodes with label country and with property country. Create if they don't exist yet. So that's what we use merge through. And as an extra step, I also want not only to create those country nodes from the country property of companies, but I want also to link the source nodes from companies to the country nodes we extract together with a relationship. And the relationship will be located in outgoing from the company node to the extracted country node, and merge as well, because we don't want to create duplicate relationships. So that's what's going to happen in the end. That's how we deal with the unideal CSV file. Well, and that's really what happens in real life, right? You never get the structure you want right away from exports, so you need to massage them a little bit to actually get to the domain representation you want for your application. And so Liquibase is not an ETL, but it can help with that. It can help with graph refactorings. As it was one of the first migration tool to actually support refactoring. So yeah. And so I will run this, and then I will come to the question right after. All right. So as you can see, here it's a very simple configuration. We are running against a local database, and as proof, I have a database running here. I'm going to open. I will prove to you that I'm not cheating. It's empty. There is nothing in it. So let's just, have it spin up. All right. Let's just connect. Here we go. And really, I'm not cheating. There is nothing in there. Cool. Nothing at all. And so by default, what the Spring Boot auto configuration does, not only does it configure Liquibase for you, but it will run the migrations at startup of the application. So you can see here, it's just a standard Spring application run. There is no Liquibase run, no explicit command like this. It's done with the auto configuration. It will configure Liquibase and run the migrations that are defined in the changelog right away. So let's just start that. And yeah, let's have a look at the log a little bit, because it's interesting. So you can see we will start a driver connecting to the database, and that we will see Liquibase logs that will go through our list of change sets and run them one by one. And so that's great. I can have a real quick look here, because time is of the essence. I will try to zoom in a bit. And we'll see different things. We have these companies located in those countries. I mean, Morocco is a sole country here without companies in our data set. Sorry about that. But yeah, you can see different things, and you can see something else, right? What are those things? And those things are part of the history graph. Because as we've told before, we don't want to run migrations that have been run again, at least by default, right? You can control that. But by default, once something has been run, we don't want to run them again. And also the incremental part, like you're not allowed to change that after the fact. So that's why there is this checksum attribute here, for instance. And as a proof, so you've seen in the logs, all these change sets have been running, right? Change set, blah, 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 blah. If I restart the application again, you will see there is much fewer logs, because we've run everything already. And with this database has not changed in between, hopefully. So you can see, yeah, application is started and you don't see the change set again because they've been run. And yes, indeed, there is a lot of SQL in the logs, in the names. We try to hide some of those, but it's not completely hidden. But you know what SQL means, right? It means some query language. And some query language, cipher language is some query language, right? So the acronym works. And so if we, and now we're super happy, right? We have country companies and we want to insert persons, right? So let's do that. We have a little person script. So I don't know if Oliver dropped bomb, the former Spring Data REST lead is watching us, but we are really doing the RESTful way, like the HATOAS way of persisting stuff. We're really using the hypermedia graph to persist things. So let's do it. We're just gonna insert a few persons, maybe. I'm gonna be lazy because I think, yeah, let's have Marouane. He's working at Neo4j from Morocco, so let's insert Marouane there. All right, so we put a few curls, and let's do it again because I don't know. I feel like we need more Marouane in the world. Okay, well, why did I do that? Oops. Oh man, I think I screwed up really. I have duplicates persons. That's not great. So let's look at the graph again. And let's look, we should see, oh man, we have 3 Marouane. So let me zoom in. Okay, yeah, we have 1 Morocco, so that's great, right? We didn't duplicate the country, we didn't duplicate the company, but we have 3 Marouanes working. That's why he's so efficient, by the way. I think he has some clones out there. So yeah, let's fix that. But first, there was a question. What about up-down migration, specifically registering new relationship as a replacement for an existing relationship? That's a great question, Jatin. Thanks for that. As we will tell at the end, we are planning to add some more specific refactorings. This one is not there yet. We'll work on it to add it. And Agung has also a very, very nice question we'll address at the end. But so registering a new relationship as a replacement, for now you have to do a custom cipher query yourself as part of the change set. We will add more and more high-level constructs so you don't have to deal with that logic yourself. And I will come back to your question right after the demo, Agung, because that's a very, very interesting one. And so, all right, so I screwed up. But, it's a production database. It's running on localhost, a very, very precious host. So I should do my best to not screw up the production data. And so let's switch branch, and we'll go to see how the fix is made. So let's go to the final state branch. And let me look at the countdown, so the final countdown maybe. Let's see. How much time do we have left? Not so much, so I'm going to speed up a bit. All right, so how can we deal with that? We have duplicate data in production because we forgot to add a uniqueness constraint. And we don't want to delete data, right? We don't want to do destructive operations. So in that case, I'm cheating a little bit, and that's an exercise left for the readers to figure out how I cheated a bit. But thanks for us, there is this merge nodes refactoring. Perfect. So I'm just going to use that. I'm just going to use merge nodes and merge nodes all together. And for every property I encounter on these person nodes, I will just keep the first one. There are different ways. You could have keep all. It will aggregate all the property values into a single array, or you keep last, you will keep the last. So that's the first step, right? So that way I go from 3 Marouane, which is great, to 1 Marouane, which is greater. And then, of course, merge nodes merge the nodes, but it merge also relationships from all these nodes. So if I stop there, I would have, because I had 3 Marouane, I would go back to 1 Marouane node, but with 3 works in and 3 located in relationships, and I don't want that. So again, for now, it's a custom cipher query. In the future, it might be a simple refactoring like we have for merge nodes or extract properties. That's something that can work in the future. And so what we're going to do, we're going to match all the persons, and we're going to aggregate the relationships, and we're going to delete the extra ones. And finally, once we've got rid of that duplication, finally, we can start creating the constraints for the name, for the person on the name. So we don't duplicate persons anymore. All right, so let's run that. And we will see in the logs. So in the second rerun, we had no change set executed, right? So let's rerun that. Now we should see, because we have at least a couple of them new, we will see new ones actually executed. So let's rerun the application. So running. And you can see running change set, merge duplicate, remove duplicate, and index person. So those new ones have not been run before. So now we're running them. And let's look at the graph now. And I'm going to zoom in a bit so you can see the history graph, the history flower, I would say, even given the shape. has grown a bit. And if we look at Morocco, I believe, here we go. Back to one Marouane, lives in Morocco, works for Neo4j, and Neo4j is still in Sweden. So that's all great. But did we solve the actual problem? Like, will there be more duplication problems? Let us see again. Let's try to insert Marouane again here and see what happens. Will it fail or not? Boom, 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 boom. So I don't know if it's very clear, but we can see a big error message here. New data does not satisfy constraint, person name CST, blah, 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 blah. They share the same property value, Marouane. We can only have one Marouane because he's the best and there is no point in cloning him again. And so, yeah, that was it for the demo. And let's move on. And I will answer your question. I promise. I did not forget it. So what's
Florent? Sorry to interrupt. Can you try to wrap it up? We are over time already.
Oh yeah, sorry. So yeah, real quick, we add more refactorings. We're gonna make it easier to create index constraints. We might even introduce a new format for ASCII doctor so you can collocate documentation and change sets. And maybe we're gonna work on this JDBC bit I mentioned. And for answering real quick for Agung, big size data is an actual topic we are currently thinking about and working on because that's very specific to Neo4j, the fact there is no clear separations between structure and data. So indeed, when you want to change the node shape, you might end up touching 1 billion nodes, and we want to make sure that Liquibase can handle it without choking on the size. So that's an active topic. That's a great question, and that's a great topic we want to work on and improve. So stay tuned, and or even better, check out the project and start contributing. Ping Marouane and I will help you contributing to it. And that's it. And Marouane, if you want to say a final word.
Yeah, and if you need any help on your modeling your projects, bootstrapping them, architecting them, we will be very pleased in PS MEA to help you with the more than 100 people, very skilled graph engineers, Neo4j engineers with this. Thank you very much for your attendance and see you soon.
Yeah, see you later. And sorry for the overtime. Bye, everyone.